Hello guys, welcome to this new video. So today we're going to talk about CI/CD. So you might be a developer and you want to push faster your code into production because you have time to market which is constrained. Or maybe you are an ops and you're tired of doing everything manually and you want to automate some things. Or maybe just a business and you want things to go faster. So let's stay tuned and let's jump into the screen to see a presentation. Okay, so now we are in the screen, so let's talk about continuous integration and continuous delivery. So, what is CI/CD? So CI/CD continuous integration for CI and continuous delivery for CD. So CI is a way how to automate the build and the check of the quality of the code, okay? And continuous delivery is how to take my project, so how to take my my application and push it into production, or maybe push it into pre-production if I want, automatically, okay? So you have some definitions here, you can read through it. So why CI/CD is important? So first of all, it's important because it's faster to fail and to recover. To say, for example, if your code doesn't work, your test will tell you, and you don't have to run your test manually, everything on your computer. So you can just have an automated process. Every time you push something on your repository, then it checks your quality of your code and says if there is errors. The process is automated, so it's less source of errors and less painful also sometimes. To push some things in production can be very annoying sometimes. Also is a standardization of the processes. So this is very important. So when we have a CI/CD, for example, let's say the CI/CD is made by one team, and if this team says, okay, the CI/CD need to work on this way, that means all the projects that will run the CI/CD will have to be on the same way. Okay, so like this, you don't have diversity inside your infrastructure. And of course, it improves the time to market because everything is automated, no human error. So yeah, just works faster and better, theoretically. Okay, what tools do we need for CI/CD? So first of all, we need a source repository, so source control repository. So for example, Git, Maven, SVN, sorry, and yeah, but the most common is Git, so we're gonna talk about Git. And after we need tools to run the test on the code and to build the code, to check the quality of the code, and then we need other tools to push to the environment. And the most important thing, after all, what we need is a lot of tests. So make sure you write tests of everything. You need tests, etc. Every test. The tests are very important. So let's talk about source control and let's talk about best practices. So a lot of people get confused here. So how we have a very clean Git repository. So this is the best practices from Git flow. So I strongly advise you to follow them. So basically what it says on the branch master, there will only be versions of the application, okay? And every time you develop a new feature, a new product or something that is related to your application, you create a branch develop, okay? And every time you want to add new stuff, you create a feature. A feature is something specific to the thing you want to add. So, for example, let's say I want to change a button color, okay? So I will create a feature, a new color button, okay? So a new branch in my Git, new color button, I will do my code and I will put there, and then when I'm finished, I will push it to the repository, okay? And when all of these features are tested and they work well, they can be merged to a branch develop, okay? And when all the features we said for this entire sprint of this new release of the application is finished, then we test it, etc. We do integration tests, etc. And when everything is working, we merge into master. But what is in master should be 100% working and should be the representation of what is in production. So for example, if we have version 0.1 in production, then the master 0.1 should be exactly the same. And there is nothing in between in the master in between the numbers of releases. Okay, so version 0.1, 0.2. There is also a theory about hotfixes. It can work, but no new features should be pushed into master without a release number. Okay, so this is for the source control best practices. Now for the CI/CD best practices, always work with pull requests. So that means every time you want to, for example, take your release and merge it to a branch develop, you do a pull request, and like this, it can trigger a peer review or a review by someone else. And even if you are alone, it's still a good practice to do it because you will never stay alone on the project. Okay. So like I said before, having a lot of tests, so we need unit tests that test the functions in your code, we need functional tests that test the functionality of your code, and we need integration tests that test your application, like integrated in the same environment as the production one. Okay, so that means with real data, for example, if you use data with same version of databases, same version of servers, etc., etc. Okay. And we need to build alerting on that. So for example, if something fails, we want the developers to be notified, or maybe the ops people who are managing the production to be notified if something fails. Okay, because if you do like a lot of pushes per day and you don't know when something goes wrong, it can be very bad. Okay. So for the CD best practices, first of all is if you use cloud, and I strongly advise to use the cloud since it's the main purpose of this channel, code your infrastructure. Don't click around on the console or whatever and do the stuff manually. No. This is bad. You should always automate your code and you should write code about your infrastructure, okay? So the code infrastructure should go in a separate repository. Like this, we have like the project, the application repository, and the source control repository. And then in between, there is some configuration. So the configuration can either be inside the application, and I strongly advise to have a configuration of infrastructure inside the application repository, just the configuration, not the code, okay? And yeah, like this, you can reuse the code for the infrastructure for different projects, for example. Okay, so always have a backup plan. So when you do a release, you don't just, okay, throw everything away and just put the new version. Okay, this can work for startups, but for big enterprise, it doesn't work. So there's different strategies. You can either do blue-green. So blue-green, that means you have like the old version, which is blue, and the new version, which is green, and you switch to green, and if the green fails, you still have the blue running, but it's not shown to the customers. So you can just switch back, changing the DNS or just the load balancer to the blue version, okay? And can be done very quick, and like this you can just roll back very easily if it doesn't work, okay? But you can do also, to improve a bit this thing before deploying, you can just do canary update. So that means you have like the two versions, the blue and green, let's say, and you just run the majority of the traffic on the blue and little bit of the traffic on the green. Like this, you test if the green works correctly, okay? One other thing is you can do rolling updates. So this depends on your application. You might be able to do it, you might not. So rolling updates, for example, if you use like different servers or different instances to run your application code, you just replace the old version of one server at the time by a new one, and you test if it works, and if it works, you continue the process until you renew all the instances, okay? So what tools we're gonna use? So for simple deployments, so for simple applications, simple projects, simple infrastructures, what we can use in AWS is code pipeline with code build and maybe code deploy, but this depends really on your application, what you're using. This works well for simple stuff, but if you want to create very complex CI/CD pipelines, I don't recommend using it. I recommend more using Jenkins or something similar, and you can use the code build plugin, AWS code build plugin inside Jenkins. That means, for example, if you know a bit about Jenkins, you have a Jenkins master and you have Jenkins workers, and the project is built on the worker, not on the master. You should never build something on the master, because if the master fails, and all your projects will not be able to be built. Okay, so you have workers running, but this is not very cost efficient. So if you use the code build plugin, every time you want to build a project, Jenkins will talk to AWS, say, okay, I want resources to run my build. AWS will give him a code build, and he will, Jenkins will be able to build the project inside the code build, and when it's done, the code build is shut down, and you only pay for the time that you build. So it's quite convenient. Another thing is to use containers. This helps a lot. So if you use containers, then you have orchestrators like Kubernetes, and the way of deploying applications is Helm. It's the most common way today how to deploy production applications inside Kubernetes. We're going to talk about this in a different tutorial later on, not today. Okay, so first thing you need to do is simplify your life. Okay, more simple will be your project. I mean, the processes were easier and less trouble source will be. Okay, so for example, if you use Docker, it's simple. You know what you run on your PC when you develop, you will run the same thing in production. Okay, even if the database is not the same, etc., but at least the code of the application will be the same. Use a container orchestration, so for example Kubernetes or ECS. There will be a tutorial coming on ECS, so we're going to see how to run ECS on AWS, and later on Kubernetes as well. Okay, spend a lot of time writing your test. So this is, yeah, like I said, like maybe many times, it's very important to have good tests for that. And then you need to know more. Also, you need to read about best practices, etc., because this is short presentation, and also, depending on the tools you're using, maybe different best practices can be applied. So read the manual. You have a link here from AWS white paper. So I strongly advise to read it. Okay. So the use case we're going to run through this demonstration is, first of all, we're going to have a Git user. I mean, will be just me. And then we have a code commit. So this is like the kind of GitHub from Amazon. So we're going to push the application code, then we will have a first stage with code build that will run a build of a test, a build of a project, sorry, and test the project. And then we will have some kind of deploy to production with what will be done by code build again, but this will require a manual approval. So it is, okay, I'm agreed to deploy into production. And all of this is defined inside AWS code pipeline, and the different builds and releases are just some tags different inside Amazon Elastic Container registry. So this is just for this demonstration. You should use different repository for building and pushing to production your code. But anyway, just to make the things more simple, okay? And if you don't know about ECR, don't worry, we're gonna talk about this on a different tutorial. For now, it's not very important. Okay. Stop talking and let's code. Well, it's already code, so I'm just going to show you how to run it. So if you go to the same source repository that I put on the description, you will be able to get this code here. So this is the folder number 4. Here, let me just stretch a little bit. ECR CICD. So inside this, you have a Terraform code. This Terraform code just build a CICD, and then you have an example of project where you have like some stuff, just very simple stuff to build a container and to run it. Okay. So first of all, we're gonna deploy the infrastructure. So let's come here, and as you can see, I am inside this folder, and I just have to do make deploy. This goes quite fast because there is no like much of AWS resources to deploy. This is only 13, and these AWS resources are quite fast to deploy, so it's perfect. I will not have to shorten the video. Maybe I will do it, maybe not. Okay, so when it's deployed, Now we just go inside our console and let's see what we did. So I'm going to click here on code commit, so you can just look for here, code commit, okay. And then, so what we just did is create a repository here. So it's my first CICD. If I click on it, for now you see it's empty, so we need to put stuff on it. Then I created 2 code builds, not here, build projects. So 2 code builds like I shown on the diagram, one for building and testing the application and one for pushing the application to like a production version number, okay? And we don't have code deploy because we don't use it now, and we have a code pipeline, and the code pipeline, what does it says? It says every time there is something pushed into a source repository, I take it, I build it, so depending on the configuration how I build it, then I deploy on prod. So deploying on production requires a manual approval, you can see here, and then if the manual approval approves the deploy, then it's deployed to production, okay? How the projects are built, this is defined by something I did in Terraform. So for example, if I go here in Terraform and then I go in build specs, and here, for example, build project, I have this step. So this is for just using ECR, you don't really need to do it. This is the build. So build is just make build of container, and then it runs make test, and on the same container, okay? And this is not very important either. So when everything passes, it just push into the ECR, okay? So in every project you should have make files. It simplifies and standardizes the process. It's better. So if I look to the make file of my project, here, I have these things that I use for the CICD. So make build is just a Docker build. Make test is just run test.sh, which is a very stupid test. Just check if the string, the output of a container is the output what we expect. So taking the output of a container, what do we expect? If the results are okay, then success, then if are not, fail. Okay, very simple. Okay, so now I'm going to push this, and for that I have these commands inside the make file, and I'm going to push this into the source control repository of what we just created in Amazon. So if I take a source repository here, for now we see there is nothing inside, okay? Sorry, this one. There is nothing inside, okay? So let's deploy this, and so here I go to my project, and then I do make, first of all, we create a Git repository inside this project. So make Git init, okay, make Git, what, don't remember the target, add and commit, so this is very simple, and then make Git push. First of all, before doing that, since we are using code commit, we need to have either a Git user or push our public key inside the code commit to just tell Amazon that we are allowed to push and deploy things there. Okay, so by default there is nothing, no such a thing. Okay, so I create a script. This one. Okay, so if we just see the script, basically what it does is taking the current user, okay, and is taking the public key, which is located here, and he push it to Amazon, okay, and then he creates a SSH configuration file saying that we need to use the private key to push the things inside the code commit. Okay, this is to be able to use it with Git. Okay, so now if I just run make AWS something, yeah, this. So I'm gonna create, I'm gonna upload my public key just for this user, tmp admin, and now I will be able to do a git push. Make git.push. Okay, perfect. So everything succeeds. So now if we go back in our repository, we will be able to see that there is some code here. Okay, perfect. So now if we go to the pipeline, we will see that the push of this code triggered an action, and this action is to run the pipeline. So the pipeline will take some minutes to run. Okay, so let's just wait a little bit. So now we see it's running. It takes some time to notify the pipeline we need to run it. So now it's building the code. So if I go here inside code build, it's going to build the container and then it's going to run the test. So if I click on the build run, so you see here it's now is in progress. So if I click here, I can see the logs, and this takes a little bit of time to start. So when we will start in, we're going to see the details of that. Okay, so now the job complete. So as you can see here, it succeeded. Let's see what it did. So under this section here, you have the logs of the build. So you can see here, we are building our Docker. So we're taking from a container, an image container, which is Alpine, and we just build some stuff. Okay, so now we have build succeed here. And then here we have run test. And what we do, it's container output is this, and we expect the value of this. So the test succeed as I shown on the previous script. Okay. So this is succeed, perfect. Now let's go back to the pipeline. And on the pipeline here now, it's waiting for a manual approval. So let's say the code build, the test passes. So all your unit tests, functional test, and integration test passes. And now you want to deploy it to production. But you are not quite sure if you want to do it like this. You maybe want to look some logs, etc., to make sure everything is right. Maybe when you get more maturity, you will be able to just to deploy and see how it goes. But for now, you can just wait until there is someone who approves this process. So here it's waiting for manual approval. You see, waiting for approval, and you can click on review and say, okay, I agree with this build, approve, and then it will deploy into production. So this will just run another code build and will just change the tag of the container, of the image. Okay, so now let's say I want to deploy a new version of my application. So I'm just going to go back in the code here, and this is what I put inside the container, just echo hello first Docker project. So now I will call this it's joke. Okay. Save it. Now I will just push it to the repository. So I do a make git add, and now I have to do a git make push, but since it's not the same command, so I'm just going to run it manually. Okay. Okay, so now we have pushed a different version. We should be able to see the pipeline triggering again and running the code again. So let's go back to the pipeline. So you see the first pipeline before just was successful. Now we should be able to see an error because the test will fail because the output we expect is not the same that we give. Okay, so let's just see if there is any progress here. So let's wait until it triggers and then we're gonna review the logs. Okay, so now the build just complete and we see there is a fail. So let's go back into the details and see what happened. So here we see the build of a container, so everything worked, build successful, okay. And here run test, container output is, it's a joke at the end, and we expect the same value without it's a joke at the end. So the test fails and we exit the program with error 1. So this concludes that if there is a test that fails, we're not going to follow the pipeline. So you see the pipeline just stopped at the build of this container and at the test of a container. So if here it's not working, then there is nothing that will be deployed to production, okay? So this concludes this video. I hope you enjoy it. It's a very simple way how to create CICD on AWS. It works for simple projects. Here we use Docker and it simplifies even more. Remember one thing, when you build a project, you should always have a makefile. Even if your code is Java or whatsoever, just have a makefile that calls Maven or something like this. And yeah, having a makefile that makes the different applications and different teams to have like the same standards of how to build the project, okay? And even if you use Jenkins and you have a Jenkins file, having a makefile is still a good value, because if one day you get rid of Jenkins, you don't lose your pipeline. You know, you just have your makefile and just run steps on with makefile, okay? So I hope you enjoyed this video. We're gonna implement something on top of this on the next coming videos, so we'll see when I will doing it, because I have different things to show as well. But what we are building now is small projects, and then at the end we will combine the projects together to make something more realistic, something that it's more like something that we can find in real world applications. Okay, so stay tuned, subscribe to the channel, and give a like, or just leave me a comment if you have questions. Okay, see you guys.